for your presence.
Hello, you there?
Yes, sir. You are audible, sir. Sir, may I request you to share one message in our platform from your side?
I'm sorry, you're going to have to repeat that, madam. Can you hear me?
Yes, sir. You are audible, sir.
Yes, sorry, I couldn't hear what you were asking, madam. Sorry.
Yes, sir. So may I request you to share one message from your side?
Yes, well, I'm a philosopher myself and a science and science fiction author. I write about many, when I say science fiction, it's hard science fiction as opposed to soft science fiction. So very technical science and so forth. Well, one of the main themes I touch on is the colonization of Mars, terraforming Mars, which is something that science fiction authors from time have written about and philosophized about and so forth. Now, in terms of it becoming a reality, we have to look at various problems. Now, one of the major problems about Mars is that it lacks a magnetic sphere. Mars lacks a magnetic sphere. Its magnetic sphere was wiped out as a result of the slowing of its magnetic core, its iron core. So the planet is subjected to enormous amounts of cosmic radiation. Can you hear me okay? Can you hear me okay?
Yes, yes, sir.
Yes.
Okay. So the planet is subjected to enormous amounts of cosmic radiation because of the lack of its magnetosphere. Gamma rays, ultraviolet light, highly energetic particles constantly bombarding the Martian surface as a result of the lack of the magnetosphere from pulsars, neutron stars, and supernova and so forth. So this poses enormous problems for man once we get to Mars, as a result, obviously a major health risk. One of the ways to deal with this would be to use robotics, artificial intelligence, machines to actually do the majority of the work in terms of terraforming the planet. And obviously, once man is on Mars, we could build special domes that are made from special alloys that have the capacity to repel deadly, lethal cosmic radiation. So once housed within the domes that have the ability to repel cosmic radiation, you would be protected. But outside of the dome, obviously, there is significant health issues because of the radiation. So one of the ways to bypass this, as I said, would be to use AI, robotics, to help the initial stages of colonizing Mars and terraforming and so forth. And then once man is on Mars, to have domes built on Mars that have the capacity to repel deadly, lethal cosmic radiation. Sorry, I can't see you. Hello? Hello?
Yes, sir.
Can you hear me? Everything?
Yes, yes, sir.
Okay?
You are audible.
Okay, so this is one of the problems. We can bypass this by building special domes on Mars that are built from special alloys that have the ability to repel lethal cosmic radiation. One of the other problems is that once we create an atmosphere on Mars, a human-friendly atmosphere on Mars, the atmosphere could be lost to outer space. The reason why is that gravity... Hello, can you hear me?
Yes, sir.
Yes, gravity and atmosphere are intercombined. In order to retain an atmosphere, you need to have a certain gravitational field. Mars's gravitational field is weak. Thus, once we create an atmosphere on Mars, a human-friendly atmosphere on Mars, it could be lost to outer space over time. So this, again, poses another issue in regards to colonizing Mars, that the atmosphere over time could be lost to outer space because the gravitational field of the planet is not substantial enough to retain an atmosphere. Another problem as well is that once we create an atmosphere on Mars, solar winds could eat away at the atmosphere. Solar winds could eat away at the atmosphere. And this is actually happening now on Mars. Mars's atmosphere, upper atmosphere and ionosphere is constantly bombarded with solar radiation, solar winds that is constantly eating away at Mars's upper atmosphere and ionosphere. And as I said, once we create an atmosphere on Mars, a human-friendly atmosphere on Mars, solar winds could eat away at the atmosphere produced. So this is another issue we have. NASA have been speaking about launching a giant magnetic shield out into space that would nullify some of this solar radiation, some of the solar winds, thus protecting the planet and the atmosphere on the planet. So these are some of the techniques as NASA have been discussing, to launch a giant magnetic shield out into space to help nullify some of these solar wind erosion processes to protect the atmosphere. So these are some of the complications that we would have on the red planet and so forth. Actually, incidentally, the distance between Mars and Earth is variable due to their elliptical orbits around the sun. At their closest point, they're separated by 57 million kilometers approximately. And at their furthest point, they're separated by about 401 million kilometers approximately. So this is another important thing to understand with regard to the actual colonization of Mars, reaching Mars, and so forth. So I speak extensively about this. Another problem is also adjusting to the weak gravitational field of the planet. Of course, this is key in the development of man. Obviously, if we go to Mars and colonize Mars, the weak gravitational field of the planet could pose a lot of health issues on man in terms of biological development, neurologically speaking, and so forth, affect the bones and so forth. There's a multitude of problems that could arise in terms of health effects as a result of the weak gravitational field. But one of the ways we could bypass this is that once we have domes on Mars, through a centrifugal force, we could simulate an Earth-like gravity, thus override this problem. So these are some of the techniques and things I discuss in my work.
Thank you, sir. Thank you. That was.
I hope.
Yes, sir.
I hope you can hear me okay.
Yeah, yes, sir. That was really wonderful to hear from you, sir. And I would here like to unmute our president, sir, Professor Dr. Ritura, sir, also to add one message from his side.
Okay, so. Okay.
Yeah, thank you very much. And this is their president, Professor Dr. Ritura here, and we would like to first appreciate my friend and Professor Anthony Fuselius, sir, the living legend that I want to share with everyone. And if anyone have gone through his books one after another, I would like to share here that one quotation from the genius Albert Einstein. He was sharing that imagination is more important than knowledge, and truly reflected in each and work of our Anthony Fuselius, sir, from United Kingdom. We have seen that today also. That was outstanding, brilliant, and incredible presentation. That's sharing that how the people can identify the problem, especially whenever he was sharing about the Mars. And of course, the gravity is always, I think, that catching the eyeballs of all the scientists, because yeah, from Newton time to, I think that if we are sharing about the special generality of relativity and even the Hawking, we have found out that every time there are new proposals, new explanations. And today, I wanted to share the mind-blowing part is that our Fuselius are explaining the new dimensions. I hope that the new researcher, those who are going for true innovations, and of course, if you are also writing down your new books, you are planning for that one, you can follow our Fuselius books. He has the books in his hands, published and already, I think, that present in Amazon and all the international platform. He is one of the living legend. Again, I'm appreciating my big hands for our Anthony Fuselius here, and I wanted to request each and everyone in this platform, please give the big hand, and we will have the more and more session in future. And today, I feel blessed to have our Fuselius here in this platform of INFES 2022, the 4th International Conference in this Eudoxia platform. Thank you very much.
It's been an honor. Thank you, sir. Thank you very much indeed. Thank you.
Thank you. Thank you very much.
Thank you.